Hello everyone, I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology, teaching you microcontroller lab experiments. Here I'll be teaching you an assembly language program to convert a given number, that is a hexadecimal number which is present in 9000 H external memory location, into two ASCII numbers which are stored in 9001 and 9002 memory location. So let's proceed to the data conversion programs. Under data conversion, I am teaching you today how to convert a hexadecimal number into two ASCII numbers. So how do we proceed first? Initially, step 1, we are going to go to the project tab under menu. Click on project tab. After you click the project tab, click on new microvision project. So I'll click on new microvision project. Here I give the name as hexadecimal because I am converting a hexadecimal number into two ASCII numbers. So I'll give the name of the file name as hexadecimal and I'll click on save. It will ask me to choose the vendor and it will ask me to choose the device. The vendor I choose is microchip, and in the search window I will type as AT89C51ED2. This is the device which is compatible with 8051 microcontroller to program in Keel Microvision. So I choose AT89C51ED2 device and I click on OK. Here I need not copy the image because the output is seen in the Keel Microvision window itself. Hence I'll click on No. As soon as I click on No, the target file will be created. Now I will go to the file menu and I will click on the new for the editor window to be enabled. Here I type the program. This is the program which I am typing to convert a hexadecimal number which is present in 9000 H, and I am converting it and storing the result in 9001 and 9002. Now let us go and check the program. After typing the program, I will go to the file menu. I will go to the save as. Here I write as hexadecimal.asm. Because it is an assembly language program, the extension file for the assembly language program is .asm. Hence, I click on .asm and I save. Now, I will proceed with the program. How? First, I need to set the crystal frequency. In the project window, there is target 1. So, right click on target 1. In this tab, I click options for target. Under crystal frequency, I type 11.0591. Under output window, I check create hex file and I click on OK. Now I have to link the hexadecimal file to this project. So in the project window, I expand target 1. Under source group 1, I choose add existing file. Here I give the file name as hexadecimal.asm and I click on add and I click on close. Now I will check for the compilation. In the menu bar, I click translate icon. It checks for the errors. It links the hexadecimal file by clicking build, and rebuild will complete the process. Under debug, in the menu tab, I click start stop debug session and I click on OK. It takes me to the screen. In this output screen, you can observe here there is a memory window. The address we are using is external, so I type X. and colon, and I type 9000H. I am giving the number over here. The number what I am giving here is the hexadecimal number. So I type here as 2C. So 2C is a hexadecimal number. To this hexadecimal number, I will be finding out what is its equivalent to ASCII numbers. So let's proceed and check. Let's do it stepwise. Step 1. The data pointer will be pointing towards the memory location 9000. The data present in 9000 is 2C, which I am going to store in accumulator. The same information will be stored in register R1. Now I am ANDing, I perform AND operation of the data that is present in the accumulator, that is 2C, with F0. Why do we perform this? To mask the number. Which number gets masked? Whenever I perform the AND operation, the most significant bit get masked and only you will get the least significant bit. So here the most significant bit is 2 and the least significant bit is C. So 2 will be masked. So you can observe I will get the answer as 20. When I do 20 as swap A, 20 becomes 02. And here I will call the converter program. So I'll go to the converter section. In converter, I'll clear the carry. After clearing the carry, the data that is present, that is 02, I'll move it to register R2. Again, I subtract 02 with 10. Why do I subtract? I would like to know whether the given number, after I perform this operation, whether the given number, the masked number, is it greater than 10 or lesser than 10. Whenever I subtract, I get to know that it is lesser than 10. So once it is lesser than 10, there is a carry. So it moves to the next. Here it is going to be added. 30 is added to the accumulator number. So it becomes 32. After it becomes 32, it will go back to the data pointer. The data pointer will be pointing towards 9001. The data that is present in accumulator 32 will be stored in the location 9001. Now I need to get back to the next number. How do I get back to the next number? Once again, I bring 2C to accumulator. I go to the converter program. I move the data again. I get 0C after masking. Now 0C is the number which is present. 0C is checked whether it is greater than 10 or lesser than 10. All of you know that 0C is greater than 10. So there will be no carry. Since there is no carry here, that is when you subtract C with A, I get 02 as the answer. Since there is no carry, the data will be moved from the required point to the accumulator. 0C is greater than, so C is added with 7. You get 13. 13 is added with 30 now. So you get 43. You go back to the data pointer. The data pointer will be pointing towards 9002. The data present in the accumulator 43 will be moved to 9002. So here the number, hexadecimal number 2C, has two ASCII numbers. One is 32 and the other one is 43. So this is how you convert a given hexadecimal number into two ASCII numbers. Thank you for watching this video. Thank you.